So introduction to trigonometry, your chapter, and in this chapter we will study the relation between the angles and the sides of triangle. In this, we will study the relation between the angles and sides of a triangle. So, suppose you have a triangle. You have a triangle. This type of triangle you have, and this angle of triangle is 90 degree. Triangle. This is triangle ABC, and this is right angled at B. And this triangle is known as right angled triangle. Right angled triangle, and triangle have three sides. This triangle have three sides, means triangle have three sides, and I am supposing the angle C or you can say angle C, or you can say angle ACB, or you can say, if I am supposing this as theta, so you can say angle C is equal to theta. This symbol is known as the theta. So we will define the relation between the sides and the angles of triangle. Now, taking this triangle, and in this triangle, if this angle is theta, so opposite to this angle, the side AB will be perpendicular. This AB is called as the perpendicular, and opposite to this 90 degree angle, this side AC is called hypotenuse. Hypotenuse. And the remaining side is base of the triangle. So I will represent perpendicular with P base with capital B, hypotenuse with capital H. I am taking the same triangle, suppose this angle is given, this angle A is given. Okay, suppose this angle is I, this angle is I, angle A is equal to I is given. So now the perpendicular, hypotenuse, perpendicular will change. That means base and perpendicular will change now. So now opposite to this angle, if you are taking the perpendicular with respect to I, if this angle is not given and this is the angle, and opposite to this angle, this side BC is perpendicular now. Means opposite to the angle, the side is perpendicular. So this is perpendicular, and always remember that opposite to the 90-degree angle, the side is hypotenuse. The side is hypotenuse and remaining side is base. Remaining side is base. So for the study of trigonometry, we should know about the triangle and the properties of the triangle we should know. Now I will discuss Pythagoras theorem. Pythagoras theorem is applicable in a right angle triangle. If you have a right angle triangle, this is angle 90-degree. If you are measuring side with respect to this angle, then this is perpendicular, this is hypotenuse, and this is base. This is triangle PQR, suppose. So Pythagoras theorem is, in a right angle triangle, the square of hypotenuse is equal to perpendicular square plus base square. This theorem is very, very important for the study of this chapter. For solving the question of this chapter, this theorem is very, very important. So this is all about the triangle and angle. Now we will discuss about the trigonometric ratios. Trigonometric ratios. So write the heading trigonometric. Trigonometric ratios. Trigonometric ratios. So what are trigonometric ratios? With the help of triangle, I will explain you. Suppose we have this triangle. So trigonometric ratios are: number one, sine of angle C. Sine of angle C is one of the trigonometric ratio, and you will write this as sin sine in short form, sine C, or you can write this sine theta. Okay. Another trigonometric ratio is cosine of angle C. You can write this cos C, or you can write this as cos theta. Number third is tangent. Tangent of angle C, you can write it as tan C, or you can write it as tan of theta. Fourth is cotangent. Cotangent cotangent of angle C, that is known as COT, cot C, or you can write it as cot theta. Fifth is secant, SECANT, secant of angle C, or this is, in short, you will write sec C is equal to sec theta. And the last is cosecant of angle C, that is, in short, you will write cosec C, and this will, you can write cosec theta. So this is just the introduction, and we will discuss this further. Just note this down. Okay, then. You can just tell me when you need to write further. When you can ask me to scroll down. You should know what is right angle triangle. This is the right angle triangle. This is the right angle triangle. This is the angle C of right angle triangle, or it can be written like this. Okay, Azan. Just change the spelling. This is A. P by T H A. This is P by T H A G O R A S. Okay. And this theorem is very, very important in this chapter. Very, very. In each and every question, you will apply this theorem. In each and every question. 99.99% questions, you will apply this Pythagoras theorem. You will be given a right angle triangle, one side will be given or angle will be given, and you have to find the other side or other angle or other trigonometric ratio. So we have yes, we have six trigonometric ratios. We have six trigonometric ratios: sine, cos, tan, cot, sec, cosec. And these trigonometric ratios, okay, fine, sorry. Uh, and these trigonometric ratios always included, always included with the angle of a triangle. The angle of a triangle. Like you have a trigonometric ratio sine, then you will write it with some angle. I will explain it later also. Just note it down. Azan, please enter in the class. Try to enter in the class on time. Okay. Just finish your all your work before the class. Before entering the class, make sure that all your works should be completed. And I know uh, this chapter is very very interesting for me, but you may get a little bit boring, but I will make it very interesting for you. Azan, should I scroll down? Okay, just write this down. So we have 6 trigonometric ratios. Trigonometric ratios: sine, cosine, tangent, cotangent, secant, cosecant. In short, we write sine, cos, tan, cot, sec, cosec, and always we write these trigonometric ratios with some angle of triangle. And there is a relation between the sides of a triangle and the angle of a triangle, and this trigonometric ratio helps us to determine the relation between the side and the angle. We will see how this trigonometric ratios helps us to define a relation between the side of a triangle and angle of a triangle. Azan, completed? Okay, very good. So we have 6 trigonometric ratios. 6 trigonometric ratios. 6 trigonometric ratios. Sine, cos, tan, cot, sec, cosec. Okay. And this sign you always take with this sign, with this trigonometric ratio, always you will take some angle. The angle can be angle A, angle B, angle C. So I am taking here angle A. You can take the angle B also, cos A, tan A, cosec A, sec A, cot A. And there is a relation between this. This cosec A is 1 upon sine A. The sec A is 1 upon cos A. This cot A is 1 upon tan A. Now, so relation between sides and angle of triangle via trigonometric ratios. When we will solve the question, all the things will be clear, all the things. So this is the triangle we have, this is the triangle we have, and all the things I will write according to this triangle. And with respect to this angle, this side AB is perpendicular, and opposite to 90-degree angle, this side AC is hypotenuse and the remaining side is base. Now if I want to write sin C, so you will write for sin C, there sin C is perpendicular divided by hypotenuse. Perpendicular divided by hypotenuse. For cos C, you will write base divided by hypotenuse. Base divided by hypotenuse. For tan of angle of C, you will write perpendicular divided by base. Perpendicular divided by base. These three things you have to learn at any cost. These three things you have to learn at any cost. And other trigonometric ratios, this one and this one and this one, you have to learn. Other trigonometric ratios we can find with the help of this. So in the beginning I have told you, if you want to write fifth, sixth, 1, 2, 3, 4, 5, this is second, this is third, this is second, this is third, fourth you want to write fifth and sixth. The opposite of sin C we can write, if we want to find cosec C, then you will write 1 upon sin C. 1 upon sin C means reverse of this. This will become hypotenuse divided by perpendicular. Sec of C is equal to 1 upon cos C. This will become base divided by hypotenuse. Cot C is 1 upon tan C. You can write this base divided by perpendicular, because this is the reciprocal, means this cosec C is the reciprocal of sin C. So when we will write 1 upon sin C, so 1 upon sin C is P by H, 1 upon sin C is H by P. So you have to remember these relations. So I am taking a question from NCERT example 1. This is the example 1 of NCERT and I will solve it. So now tan A is given, tan A is given, and we have to find other trigonometric ratios of angle A. Means tan A is given as 4 divided by 3. 4 divided by 3 is given. And what is tan? Just go to tan. Tan of any angle. This is not, this formula is not only for tan of angle C, but this you can write perpendicular by base for tan of any angle. So tan of A you will write perpendicular divided by base. Perpendicular divided by base. Now, always make a triangle. Always make a triangle like this, and this angle is A, and take a triangle ABC. So you are just with respect to this angle A, this side is perpendicular, this side is base, this side is hypotenuse. Okay. So apply the Pythagoras theorem. After that, you have to apply the Pythagoras theorem. So Pythagoras theorem is hypotenuse square is equal to perpendicular square plus base square. Now, hypotenuse square and perpendicular is 4. Perpendicular is given as 4 and base is given as 3. Base is given as 3. So perpendicular square means 4 square and this will become 3 square. 4 4 is 16. 3 3 is 9. So this will become 25. So hypotenuse square is equal to 25. Take the under root on both the sides. So h square, under root of h square is h. Under root of 25 is 5. Means hypotenuse we have as 5. So now we can find other trigonometric ratios. Other trigonometric ratios means we have sine. We can find now cos, cosec, sec, and all the trigonometric ratios we can find. So if I want to find cos of A, then cos of A is B divided by H. What is base? Base here is 3. Base is 3 here. And hypotenuse here is 5. So cos of A is 5. Okay. If you want to find sine A, so sine of any angle is given by perpendicular divided by hypotenuse. So perpendicular is this. Perpendicular is this. This 4. Perpendicular is 4 and hypotenuse is 5. So this is the required answer. You can also find other trigonometric ratios. Suppose you want to find cot A, then you will write 1 upon tan A. And tan A is this, you will write 3 by 4. For sec A, you will write 1 upon cos A. So cos A is this. This is cos A is 3 by 5. 1 upon cos A is 5 by 3. For cosec A, 1 upon sine A, and Sine A is 4 by 5, 1 upon sine A is 5 by 4. So in this way you can get the answer. You can just note it down. So this trigonometric ratio, this sine, this cos and tan and all that are defining the relation between this angle C of triangle and this perpendicular hypotenuse are the sides of the triangle. Just note it down. As this is the introduction of, this is the first class of trigonometric ratio. So I have only told you the basic things only. In the second class of trigonometric ratio, we will solve some good questions. But for that, you should know all the things that I have told you. What is right angle triangle and what is perpendicular in right angle triangle, what is base in right angle triangle, what is hypotenuse in right angle triangle, and what is Pythagoras theorem, what is sine of angle of A of any triangle, what is cos of angle of A, means what is sine of any angle, what is cos of any angle. Okay. Okay. So Azan, before coming to the class uh, of maths class, revise this that you have written. All the things. We will continue this class after means okay, finished. So Azan, we have started this chapter, and if you will follow that I am saying that, then this chapter becomes so much easier than the quadratic means coordinate geometry. And one thing I want to add, you will have a test of 20 minutes in the next class of coordinate geometry. Okay, so just listen one thing. Mm, So in coordinate geometry, just I am telling what you have to prepare for. So chapter number 7 of NCERT. So you have to revise, you should try to revise. Example I have already covered, but you can revise the examples also. And exercise 7.1 and 7.2 is the part of your syllabus, and exercise 7.3 now not in the part of your syllabus, means the area of triangle part is not in your syllabus. If there are few questions of exercise 7.3 that is in your syllabus, but I suggest you just mainly focus on exercise 7.1 and 7.2, means distance formula and the section formula, question based on distance formula. And we will have a test of 20 to 25 minutes in the next maths class, and after the test we will continue our trigonometry. So okay Azan, thank you. Just you can leave.